Give me a reason that A does not belong. It's the only one still in the parentheses, that is true. What do we call it when it's written with parentheses in this unit? Factor form. Good. So you could say, using like your math vocabulary, A is the only one in factor form. The rest are in standard form. So that's why A doesn't belong. Good. Table 4. Give me a reason that B does not belong. Okay, it's the only one with 3x squared. The rest of them are just 1x squared. And this, when you do multiply it out, is just 1x squared. So this one is the only one where A is not 1. So in the rest of these, A is 1. If you don't know what I mean by A, it's the number in front of the x squared term. So today we're actually going to learn how to factor it when A is not 1. Table 5, give me a reason that C does not belong. Good. Two-term expression. Does anyone remember how we factored two-term expressions? We can only factor them if they are, okay, a difference of what? Perfect. First part took a long time to get to that. Difference of squares. The only way we know how to factor two-term expressions is if it's a difference of squares, which basically means it has to be a subtraction problem. C is a subtraction problem. And there has to be perfect squares on each side of the subtraction problem. So what's the square root of x squared? X. And then what's the square root of 25? And the way that the difference of squares rule works is it has like your square roots, like how I wrote them, but then with opposite symbols like this. And that's just a rule. One day we'll probably make a flow chart if you could write it down. If it's a two-term expression, we see if it's a difference of squares. If it is, this factor form would look something like this. Where it's like the same parentheses, but with opposite signs. Good, questions on that? Okay. Table 6, why does B not belong? That does what? That adds twice. Okay. Let's see, that is correct. The only one that has both terms as positive, so positive C. I'll just put positive B and C because that would refer to like these numbers. All right, anyone else want to add to that? There is another reason it doesn't belong, but you might not have seen it unless you actually tried factoring it. So how do we factor when it's a three-term expression like this? What do we usually set up? Good, so the diamond method or AC method, it has lots of names. And then the way that we set it up is where we're multiplying to get this number. That's what we noticed one day, is that when we multiply things out, the constant is always the product of those two numbers. And then this was always the sum of those two numbers. Can you guys think of any numbers that multiply to 3, but at the same time add to 2? Now, does that multiply to a positive 3? So can anyone think of any two numbers that do that? Multiply to 3 but add to 2? So there's no two numbers that make it work. So it's not factorable. What do we call things that aren't factorable? Okay, good. So B also doesn't belong because it's prime. So sometimes that happens. Also, I should have mentioned, like, you always check for a GCF first. There's no GCF between 1, 2, and 3. And not all of them have X's, so there's just no GCF. You should still check for a GCF first, but that one is actually, so that's another reason it doesn't belong. Questions on the warm-up? Okay, so like I mentioned before, today we are doing lesson 10, and it's the last rewriting quadratics into factored form lesson. There was like 4 different parts. Factoring is a really big skill. You'll see it again next year and your junior year. So as much as you might not like it, the faster you buy into it, the easier the rest of your high school math will be. And I actually think it's more like a puzzle, so it's like really not like the worst thing to learn, in my opinion. All right, but we're gonna transform more complicated quadratic expressions, specifically when A is not 1. The process is still really similar to what we've seen before, but there's just a couple added steps, so that's what we're doing today. Puzzle piece is lesson 10, so we're back to online practices. The only not online practice was yesterday's. Should you want more points than what you earned when I checked it, then just upload it to Google. All right, don't just like feed on it. There's lots of ways you can check your answers online. Like you can use things like photo math, like other things that can help you learn. But if you're just using it as your first step, like or as a replacement to learning, like it's not a good strategy. Don't recommend. I will let you know when the next quiz is. I haven't decided yet, but the rest of the dates are more important anyway. Those are big effects on your grade. The binder check, the unit tests, your final, you're almost to the end. So questions on anything? Okay. Because of time purposes, I do want to skip, oh wait, no, we could do this part. This is a unit 6 still. Going from factored form to standard form. How do we do that? Double distribute, FOIL, diagram, box method, whatever you want to call it. But basically to go from factor to standard, you just multiply these out. So remind yourself how to do that, because doing that will help you check your answers at the end of it. So go from factored form to standard form. We'll go over that in just a couple minutes. Tell me what you got for the standard form of the first one. 3x squared plus 4. So you're saying that like the middle terms canceled? Or the linear term canceled? Okay. So I like foiling. To me, that's the less like messy one, but you have room, like you could do the diagram, whatever you guys like better. But FOIL stands for first, outer, inner, last. So multiply your first terms in each parentheses. You do get 3x squared. Multiply your outer terms. Class, what's 3x times 4? 12x. Multiply your inner terms, what's 1 times x? And then multiply your last terms, 1 times 4 is 4. So you still gotta do like the outer and the inner, however you want to refer to it. And then combine like terms gives you the final answer of 3x squared, class, which 12x plus 1x. 13. Good, and then plus 4. The linear term, like the middle term, only goes away if it's a difference of squares, which this isn't. Like this doesn't look like A plus B, A minus B, like these are all different numbers and things like that. So you should expect it to be a three-term. Questions on that? Okay, so then table 8, can you tell me what you got for the next standard form?
X squared plus 8x plus 4.
Okay, that sounds good. When I do my outer terms, I got 6x plus my inner terms, I have 2x. So yes, that does make it 8x in the middle. Table 9, can you tell me the last standard form?
3x squared plus 7x plus 4.
Okay, let me just double check. Outer terms is 3x, inner terms is 4x, that does combine to 7x. Now, this problem, I think, was trying to get you to recognize a pattern, almost like a shortcut. Personally, like when I study, I like to memorize fewer things. So I just know how to multiply no matter what it is. But if you notice, they always had a 3x and a 4, and that affected your first and your last. The middle terms, depending on what they were, add to something, you could memorize that pattern, but to me, like, just know how to multiply, know how to check your answers. Because what we're gonna do now is go from the standard form to the factor form. And I mentioned before, if you are not happy with your unit 6 test score, all of like the same concepts pop up in those units. So should you want to come after school and ask to do corrections on your unit 6 test, you might have a better understanding than when you took it way back when. There's a suggestion, but any questions? We all know how to go from factor to standards. So now we're gonna skip to make it simpler part. Our main focus is factoring when A is not 1. So I have an example for you, and you should write the steps here as we go. First step, always in any problem that it tells you to solve by factoring, you have to look for and factor out a GCF when necessary. So step 1, look for and factor out a GCF when necessary. So not every single problem will have a GCF, but that's always like the very first thing you should look for. You can't just jump into factoring without checking for and factoring out a GCF when necessary. It's almost like when we would solve before and we always said distribute if necessary. It won't happen in every problem, but you always check for that first. So let's check for that. Here's the example. You always check for a GCF between the numbers first. And don't shout it out yet, because other people kind of think not everyone is as smart as you. 4, 28, and 45. Can you think of a GCF between those 3 numbers? All right. Does 4 divide evenly into the other numbers? Not sure, use calculator. So your GCF can never be bigger than your smallest number. So that's why I'm asking. Is 4 the GCF? All right, 4 doesn't divide evenly into the other, so it can't be. If you break 4 down into its prime factors, one of its factors is 2. Is 2 the GCF? Does 2 divide evenly into the other? It doesn't divide evenly into 45, so there's no GCF between the numbers. Check if there's a GCF between the variables. Do they all have an X? So then no GCF, we move on to step 2. Which, if it's a trinomial, you will still use the diamond method. We'll just have some additional steps after this. But setting up your diamond is still gonna be the same. You're still gonna want A times C on top. So in this one, my A is 4. My C is 45, so I'm gonna do 4 times 45. Which is 180, that'll go on top of my diamond. And then what's my B value? 28. Now we're looking for two numbers that multiply to the top and add to the bottom. Normally, I just remember that that's what I have to do. If you need to draw it in your diagram, then by all means. We want to multiply to 180, add to 28. There's lots of combinations of numbers that multiply to 180. So which one would add to 28? So if you're not sure, like I said, lots of numbers multiply to 180, you can make a list and see, is there any possible way I could get 28 when I add that? So 180 times 1 would absolutely not work. 2 times 90, again, would not work. 3 times, I want to say 60, but let me just double check. Still wouldn't work, but it's showing you how to problem solve. If you guys find it before I get to it, I already know what it is, but we're looking for two numbers that multiply to the top and add to the bottom. Going down my list of numbers, so hopefully get other people to the same place. 4 times 45 does not give me 28 when I add. 5 times something, 180 divided by 5. 5 times 36 will not give me 28. Guess you're gonna need to go all the way down the list, no one has it yet. Okay, 10 and 18. To make it work, doesn't it? Questions on that? That's not the new part, I'm a little concerned, are we live? Do we see how that multiplies to the top and adds to the bottom? If not, make a list, kind of like how I did, but it went all the way up to 10, so that would be a pretty big list, but do what you need to do. That's what you get initially for your factors. Previously, we'd be done at that point. But if you go to check your answer, x times x is not 4x squared. So that's why we have these added steps. So first look for a GCF, second do your diamond method, remember A times C. Third, you are going to divide your factors by A. So what was A in this one? What was A? 4, thank you. So I need to divide each factor by my A, which is 4. It looks something like this. So you divide your factors by A. In that same step, you will reduce the fractions. Now I know a handful of you, especially anytime a fraction comes up, you just skip that problem. There's no reason, especially if you have a calculator. Basically, all calculators have a fraction to decimal point. You could type in like 10 over 4 would be the one I need to reduce. It'll give you a decimal, but if you just press this button, it'll give you the simplified fraction. Otherwise, you're thinking of what two numbers, like what do these numbers share, like what divides evenly into the both of them, and then reducing that way, or just use the calculator. I don't really care either way, but you need to be able to reduce the fraction. If it reduces to a whole number, then great. But you need to reduce the fraction. So 2 goes into both of these, it becomes 5/2. What does 18/4 reduce to? What goes into both 18 and 4? Oh wait, you gotta do any calculator, I'm not asking very hard stuff. You like good grade. What goes into both 18 and 4? So 2 goes into both 18 and 4. It reduces to 9/2. 18 divided by 2 is 9. 4 divided by 2 is 2. Yeah. So you reduce the fractions. The last step would be to slide any remaining denominators in front of the variable. So slide any remaining denominators in front of the variable. Which you should have to at least once. Here I have to do it twice. Because I have 2 remaining denominators. But that's what gives you that different number in front of the x squared. Once I slide my remaining denominators, this first parentheses becomes 2x plus 5. Second one becomes 2x plus 9. And now when I go and check my answer by multiplying, by quarterly, double distributing, whatever, 2x times 2x is 4x squared. 5 times 9 is 45. And then if you do your inner terms, you get 18x plus 10x is 28x. So that's how we're getting that. Sorry that it took a million years to explain it, but it's hard when you can't even tell me like if 2 numbers multiplied to a number. Like, that's what it is. So the only new things are these last 2 steps. All right, questions, comments, concerns? I'll show you one more, and then I'm gonna give you time to try all of the ones on the back. So I'll show you one more. Hopefully it goes by a bit quicker. I'm gonna cut and paste these steps real quick. Okay, so the one we'll do together will be the 6y squared minus y minus 2. And here's my steps just for reference. First step is to look for and factor out a GCF when necessary. So is there a GCF between 6, 1, and 2? All right, whenever one of the coefficients is 1, there's not going to be a GCF between the numbers. So then is there a GCF between the variables? Do they all have a y? So no GCF, move on to the next step, which is to set up your line. So remember, it's a times c on top. So you're gonna multiply the a by the c, what, 6 times -2? -12. And then b goes on the bottom. What number is in my b position? -1. Because b is always in front of the middle term, right? So it's a -1. But it's not written in as minus. All right, now we're thinking of 2 numbers that multiply to the top, add to the bottom. There's only a few numbers that multiply to 12. So what numbers multiply to a -12 and add to a -1? Fine. -4, +3 works. Again, there's only a few numbers that multiply to 12 in general. I would go down the list, like 1 times the number, 2 times the number, so 2 times 6, 3 times the number, and then it starts to overlap. So yeah, it would have to be -4 and +3 if it adds to a negative. Before, we used to just be done at this step. But what do I have to do after this step now, if A is not 1? What does it say, like? Out of right here even? What do we do after this step? You divide the factors by A, what was A in this one? And reduce the fractions. Use a calculator if you need to, but like, I shouldn't have to wait longer than maybe 10 seconds for you to tell me what 4/6 reduces to. What does 4/6 reduce to? What does 3/6 reduce to? 1/3. 1/2, okay, we got this one. Now what does 4/6 reduce to? 2/3. All right, we reduce the fractions, slide any remaining denominators in front of the variable. I have 2 remaining denominators, so they both need to be slid in front of their respective variables and rewrite it. My final answer for this factored is 3y minus 2. And 2y plus 1. A lot of people will say like slide and divide. So they'll slide the A, multiply it by the C factor. And then divide the A, but then you also have to slide again. So it's like slide, divide, and slide. Or just remember these 2 added steps to what we've been doing. Questions before I let you try? So that whole page is all worth attempting at 10:17, like 9 minutes from now. I will share the answers. We can go over any that you have questions on, but really like it's all based on you. Like you need to try them. I know how to do all of them. I cannot make you understand them, like you have to try to understand them. And then I can clear up any questions you have. So do as many as you can at 10:17, we'll go over them. Okay. What about you? But for this one, 3x squared plus 16x plus 5, the answer is in parentheses x plus 5 and then 3x plus 1. Yes, you can change the order of the parentheses, like you could put the 3x plus 1 first, the x plus 5 second, but that's what it is. For this one, the 10x squared minus 41x plus 4. That final answer would have been x minus 4 and 10x minus 1. Over here, this one, 6x squared minus 19x plus 15. If you did that right, you would have had 2x minus 3 and 3x minus 5. Which of these do we need to see? Any? Let's try. I don't anticipate needing to do all 3 of them, but if so, like which one would be one you'd like to see? So, got them all right? You want to see the second one, 3x squared, that one? Okay, the 10x squared. So, follow the steps, you should always check for a GCF first, and then we'll definitely make sure to do a GCF problem later too. But I'm gonna erase this answer for right now. We are looking for a GCF between 10, 41, and 4. Is there one? What is it? So I think you're going a little bit ahead. We always check for a GCF first. Is there a GCF in this problem that I need to factor out? So then we skip to step 2, which is to set up your diamond. So A times C on top, B on the bottom. What needs to go on the top of my diamond? 40. 10 times 4 is 40. What needs to go on the bottom? Negative 41. Questions on that setup? Okay. What multiplies to 40 that adds to negative 41? Negative 1 and negative 40. They both have to be negative to make this work. Because it multiplies to a positive, adds to a negative. Now, previously, we used to be done at this step. But now that A is not 1, I have to remember to divide the factors by A. What's my A in this? So I'm going to divide each factor by 10. If it reduces to a whole number, great. If not, just make sure it's a fully simplified fraction before you do the last step. I can't simplify this fraction anymore. Over here, what's negative 40 divided by 10? So this parentheses just becomes x minus 4. Over here, this is already a reduced fraction, but you have to slide any remaining denominators in front of the variable. You should do that at least once, so that when you do check your answer, you are now getting the 10x squared. But this part becomes 10x minus 1. And then when I multiply them, now I'm getting the 10x squared. Now I'm getting a positive 4, and then the middle term. Does that make sense? All right. I do want to show you a GCF problem, so we're going to go to that next. We're going to look at this one, the 2a squared plus 2a minus 24. I know they're not numbered. But here's an example that actually has a GCF we can factor out. You should always check for it first. What is the GCF between 2, 2, and 24? All right, what do you think? GCF? 2 is my GCF. Your GCF, you always write outside of parentheses. Inside is what you get from dividing each term by the GCF. So then I have a squared plus a minus 12. So all I did was divide the GCF and put it outside the parentheses. Now, sometimes you do that and then you're finished at that step, but now you need to check to see if the parentheses can be factored anymore. And since it is a trinomial, I am going to set up my diamond method. This one we've done before, like where a is 1 in front of the x squared term. But negative 12 on top, 1 on the bottom. What multiplies to negative 12 adds to positive 1. Would 1 and 12 ever possibly work? Would 2 times 6? So 3 times 4? There's no other numbers that multiply to 12, so. If it multiplies to a negative, one of them has to be negative. Which one, if it's gonna add to a positive? Okay, good. Now, in this one, since right here, like GCF doesn't count as an A, like this is just gonna stay in our answer outside the parentheses. For this, since it's like a basic trinomial, I am done at this step. If I do multiply these out, I do get A squared plus A minus 12. And then just make sure your GCF is still in there. Questions on that? Okay. So, yeah, otherwise, if A was not one, you can continue with the other subset you learned. Before you guys leave, can you make sure you at least try this one? And then I'll put the answer up. If anyone has questions about any others, like I have all the answers, you can ask. But definitely try this one where there is a GCF you need to factor out first. A lot of people have. It's this part. There is a GCF, you do have to factor it out. And then once you do, it stays in your final answer. Like I should have my GCF outside the parentheses, like it's shown here. Here's what I got from factoring it out. So divide each term by your GCF. This is what you get. Set up your diamond. 6 times -1 is -6. My B term is 1. Looking for two numbers that multiply to the top and add to the bottom. -2 and 3 make that work. Now I'm not finished here because A is not 1. What do I do from this point forward? And then reduce the fraction. What does 2/6 reduce to? No. Smaller number over bigger one. 1/3. What does 3/6 reduce to? And this is not my final answer.
Good morning, Stallions. A quick update on in the sports world here. Huge congratulations to our softball team, back-to-back champs, 17-1 record, 12-game winning streak. Come out, we'll report them tomorrow, and